Dear students, greetings. In this video lecture, we are going to discuss about forward error correction techniques. In previous video lecture, we have discussed about the CRC codes, cyclic redundancy check codes. There is a divisor is there, so data word is there. We can apply the division operation and we will perform the XORing operations. Finally, we will get the remainder. That remainder will replace with the extra redundancy bit, which is we are added in the data word. Finally, we are generate the code word. In the receiver side, we can check the same data is received or not. So CRC method is especially used for only error detection. Error is there or not. But this video lecture, we are going to identify the error, in which position the error is occurred, then we can correct the errors. Okay, this is error correction techniques. So for that, we are going to discuss about Hamming code method for finding the error. It is mainly used for single bit error. It is not used for burst error. We are used for single bit error. So we are going to discuss this topic. So this topic comes under CDT classroom discussion topic unit 2. Okay. So this is classroom discussion topic 16. So today we are going to discuss about Hamming code method, how to identify the error. So before starting the lecture, we must know the outcome of this lecture. After listening to this video lecture, as a student, you will be able to correct the single bit error using Hamming code techniques. Okay, if any data word they are given, you can identify, you can generate the code word. Then, if any error is there, you can identify which bit have the error. Then it will be rectified and it will be corrected. So, what is Hamming code? Hamming code is the technique which is developed by R.W. Hamming. The author name is Hamming. That's why the code is the Hamming code. Okay. This method corrects the error by finding the state at which the error is occurred. Okay, so where the error has occurred, that will be the simple example we will take. This is the input data. Okay, so 1001 101 is to be transmitted. Okay, so the data word is here. The data word is 1001 101. So now we are going to implement the Hamming code techniques. What is Hamming code techniques? When we are thinking about the Hamming code, we must be remember this formula. Okay, so first step of the Hamming code is calculating number of redundancy bits required. How many data we are sending, how many redundancy bit is required, that we are going to calculate. For that, we are using this formula. So initially here, if in case this is the data word, we know that the data word, how many bits are there? 1, 2, 3, 4, 5, 6, 7. So total 7 bits are there. Okay. For 7 bits, how many redundancy bit is required, that we are going to calculate. So what is the R value here? So R value we have to identify. Okay. The formula is to greater than or equal to M plus R plus 1. M is number of bits available in the data word. Okay, so here 2 power R. So initially R value equal to 1. How to identify if 2 power 1 greater than or equal to M value is 7, R value we don't know. So now we are assuming that is 1. So then plus 1. So 2 power 1 is 2, greater than or equal to 7 plus 1, 8, 8 plus 1, 9. So condition fails. Now R equal to 2. You are assuming like that. So 2 power 2 greater than or equal to, again the values. M value is 7 plus R value is 2 plus 1. So here 4 greater than or equal to 10. So this is also wrong. So now R equal to 3. So what happened? 2 power 3 greater than or equal to M value 7 plus R value 3 plus 1. So 2 power 3 8 greater than or equal to 11. So this is also failed. So now R equal to 4. Okay, so R equal to 4 means 2 power 4 greater than or equal to M value is 7 plus R value 4 plus 1. So here 2 power 4 is 16 greater than or equal to 7 plus 4 11, 11 plus 1 12. So this condition true. So we can find this condition R equal to 4. So here, that's why we need R redundancy bit. R means 4 values. 4 redundancy bit we need to transmit 7 bit of data. Okay. So till now we know that exact number of redundancy bits required to be embedded with a particular data. So now we know 7 bit is there. Then we are sending 4 redundancy bit to send the 7 bit of data. So then what is the next task to determine the position at which these redundancy bit will be placed within the data unit. Okay, so 7 bits are there, 1001, 101, we are taken as the data word. In this data words, where we are fixing this 4 redundancy bit that we have to identify. So where we are fixing it, these redundancy bits are placed at the position which correspond to the power of 2. Okay, power of 2 means 2 power 0, 2 power 1, 2 power 2, 2 power 3, like that. So how many redundancy bit is there? We have 4. So 4 2 power values we have taken. What is the position? 2 power 0, anything power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8. So in this data position, so here the 7 bits are there. So these 2 power n values, we will take the redundancy bit that we will discuss in the next slide. Okay, so you see here total 7 bits are data word, 4 bits are redundancy, total 11 bits. Okay, so 11 bits are there. So here, wherever we will fix the redundancy bit, the redundancy bit in the 2 power n position 1, 2, 4, and 8. Okay, so the 4 redundancy bit we are added with this 7 bit of data word. So finally, these are the places we have to add the redundancy bit. Okay. In Hamming code, each orbit is the VRC. VRC means virtual redundancy check. Okay, virtual redundancy check for one combination of data bits. So R1 is the VRC bit for the one combination of data bits. R2 is another combination of data bits. Okay, so how we can calculate the R1, R2, R3, R4? So see here this diagram. So here I am just calculating the values wherever, no, sorry. So up to 15. So why we will consider this 4 bit means 84214 will use up to 15, 0 to 15. So, but what are the values we are taken up to 7 plus 4, 11. Yes. So total 11 numbers. So up to 11 bits you can take the values. Okay. Up to 11 bits you will take the values. Here. So you just consider in top I written no R1, R2, R4, R8. Okay, like that you will consider. Wherever the values are 1 is there, wherever the values 1 is there, that we will consider. Here, what is the value here? This for 1, 3, 5, 7, 9, 11. Okay, so I written in the bottom, this R1, R1 bits are 1, 3, 5, 7, 9, 11. Wherever 1 is there, I am taken. Okay. Then R2, what is R2? Wherever 1 is there, 2, 3, and 6, 7, and 10, 11. So these are the values I consider as the R2. In R4, 4, 5, 6, 7. The remaining all are zeros. So 4, 5, 6, 7 position I will take. So R8, 8, 9, 10, 11. So that is I am taken here. Okay. So these are the bit combination we will take. Now we are going to apply the XOR values. So here these are the positions we are considered for finding the redundancy bit, and this is the data word we are taken. So now 7 plus 4, 11 values are there. So 1 to 11 I posted here the position. Wherever the R is there, I given in the red color. Okay. So instead of that, R value R1, R2, R4, R8 I kept. Then remaining data is filled from left to right. 1, 0, 0, 1, 1, 0, 1. Okay. So after identifying this, we have to find the what is the R1 value. So now we know that position of it here. What are the position we are going to finalize? 1, 3, 5, 7, 9, 11. So we know that these position values, whatever values are here, no, this table. This table, whatever values are there, I filled it. That one R1 is there. Okay. So if I will give 1, I will get what is the value. So you have to identify XR values 1, 0, 1, 0, 1. How many ones are there? 3 ones are there. If the number is odd numbers, odd number of ones is there means you can add 1. Okay. If odd number of ones are there means you can apply the XR gate. How to apply the XR gate? 1 XR 0. After finding this result, we can perform this operation. So after applying that all the XR values, we will get the value. What is the value we are getting? 1. So R1 equal to 1. Same like that R2. So here even number of ones are there. 1, 2, 3, 4. Even number of 4 ones, no. That's why even number means we will give 0. After applying the XR gate, we will get 0 value. Here again even number is there, so I given 0. So here only 1 is there, so odd number is there. Odd number means 1. So R1 equal to 1, R2 equal to 0, R4 equal to 0, R8 equal to 1. Okay. So now what is the code word? Code word is, we know that R1 value, R2 value. Now just we are filling it. Okay. What is R1 value? 1, R2 value 0, R4 value 0, R8 value 1. So this is the code word we are sending to receiver. Okay, code word we are sending to receiver. So if in case receiver side receiving the same information, no problem. In case receiver side is receiving any error, so you consider 7th bit. Okay. So I am just changing 7th bit is 1, but I am changing 7th bit 1 to 0. So you consider this is the received by receiver. Okay. This entire frame is received by receiver. So what happens? 7th bit error is there. When we are doing this, we know where is the error, but when data streaming, the system don't know where error is there. So how to check the error? For that, the following diagram is there. Same position we are using that. Okay. So for R1, how we are calculating the positions? We have the received data, like these values are there. So whatever value we are filling, 1, 3, 5, 7, 9, 11. Okay. So these position values we will take and XOR it. The finally we will get value is 1. Okay. So here 1 is there. So here what are the position we will take? Second position, third position, then 6th position, 7th position. For R2 I am saying. Okay. 10th position and 11th position. Already we know that formula also. Here we are seeing that R1, R2, what are the positions we are taken. Okay. So now after identifying that the R2 value is 1, XOR applications. Here, when you are applying this, here also odd number of ones are there. So R3 equal to 1. So here when we are calculating the even number is there. So R8 equal to 0. So what is the value we are getting? 0, 1, 1, 1. So how we can write it? R2, R4, R8 values. If you are writing like this, so what is the value of this 0, 111? That is 7. So 7th bit have the error. Okay, that we are identified. So what is the 7th bit? 0 is there. Okay. So if it is 0 means we will change it to 1. That is the error correction. We will change the 1 means the data will be correct. Okay. So now we are completed the Hamming code distance method, how to identify the error for single bit error concept. Okay. So now I given the data word, you have to apply the Hamming code techniques and identify where the error is there or not. Okay. So after converting this data word, how many redundancy bit is required? After adding the redundancy bit, we have to check, assume somewhere some error is there in the data word. So example, here it is there, no? We just change instead of 1, became 0, then you will check in the receiver side, are you identified the correct position or not. Okay, this is for lecture level problems. Thank you very much for listening this video lecture. So after listening to this video lecture, you will be able to correct the single bit error using Hamming code techniques. Now you have the capability to identify the error where the error is occurred while transmitting the data. Okay. Thank you very much. If any query is there, you just post the query or you just ask in classroom. Okay. So the next classroom discussion topic is data link layer protocol. We will discuss this topic in the next video. Thank you all.